Hello and welcome to another GCSE revision video. In this video we're going to look at scalars and vectors. Now a variable that holds just a single value is called a scalar. For the vast majority of the GCSE syllabus, every variable we have looked at is a scalar. There is no reason that a variable has to contain just one piece of information though. The variables we've been dealing with so far only has one piece of information, and that is called magnitude. Although a lot can be achieved with just the magnitude or size, a lot more can be achieved if we add another piece of information to the variable. Now a variable that contains both magnitude and direction is called a vector. We can use the same Cartesian coordinate system to describe vectors as we have been using to plot graphs. Now a vector can be shown as an arrow. Now an arrow has a head and a tail. The pointy end or the triangular bit at the top is called the head, and the long stick part is called the tail. We can also represent a vector as two numbers inside a set of brackets with one number over the top of the other number. Now the top number represents the number of units to the right of the tail that the head is, and the bottom number represents the number of units above the tail that the head is. So we can consider the arrow where we're looking at the x, y coordinates of the head of the arrow as seen from the very end of the tail of the arrow. So in this case, vector A is written 4, 3 with the 4 above the 3 in brackets. Now what that means is that the tip of the tail, wherever we put the tip of the tail, we count 4 units to the right of the tail and 3 units above the tail, and that's where we draw the head of the arrow. If the head of the arrow is to the left of the tail, then the top number is negative. If the head is lower down than the tail, then the bottom number is negative. And since we don't use an origin, the vector can be anywhere in two-dimensional space. So all of the vectors marked A on this grid are exactly the same vector. The position is completely irrelevant. Now when writing a vector variable, we can either put an arrow over the variable name or print the name in boldface font to distinguish it from a scalar variable. Both are equally valid, but it's easier and therefore more often preferred to write an arrow over the variable if writing by hand, and to use the boldface font if typing. But that's not a hard and fast rule, it's just more convenient. For your exam, you should be familiar with both methods of communicating that a variable is a vector and not a scalar. When defining a vector, the values inside the brackets are called components. And the components of a vector do not necessarily have to be numbers. The scalar variables x and y form the components of vector A. Okay, well, so much for the theory. Let's have a go at putting that into practice. Can you draw this vector as an arrow on a grid? Take your time, pause the video. When you're ready for the answer, just press play. Okay, so how did you get on with that question? Now we're told, can you draw this vector as an arrow on a grid? And the vector is 2 and -3. Okay, so vector A is equal to 2 and -3. So the important thing is the vector's called vector A, and it's 2 and -3. So that's 2 along the x-axis and -3 along the y-axis. Now, if you'd have decided to draw a scale like this, and then you'd started from your origin, and then you'd drawn 2 along the x-axis and 3 down the y-axis. So I think that's here, is it? Yes. That's the point. And then you draw your little arrowhead. If you'd have drawn that, then that's absolutely fine. Just remember to label your vector, and that's absolutely fine. Nothing wrong with that whatsoever. Perfectly good. Give yourself full marks. However, if you'd have decided to draw your vector somewhere up here, and let's say at 1,7, and then you drew 2 along the x-axis, so that one becomes a 3. And then you go 3 down from 7, so that takes it down to 4. There we go. 3, 4. And then you draw your head, arrowhead here. And then you label that A. If you'd have done that, then that too is fine. Absolutely fine. There is no law that says you have to start from the origin. You could start anywhere, so long as your vector goes across 2 and down 3. You could have done it in the negative y or negative x, or the negative x and negative y. You can do it in sector 1, 2, 3, 4, any sector, anywhere. You can draw it from any point, so long as it's going 2 units to the right and 3 units down, then you would be correct. And if you'd have dispensed with a scale altogether and just said, well, I'm just going to draw it in the middle of nowhere, and I'm going to say that 1 square is 1 unit instead of using these axes, if we didn't have that at all, and you'd just drawn from anywhere, and you'd have done 2 little squares across and 3 little squares down. Let's make sure I've got that right. 1, 2 across, and 1. That's 2 across. That's 1, 2. That's 2 down, not 3 down, I think. That's 1. My eyes don't focus very well, I'm afraid. So that's 1, 2, 3 down. I think that's 3 down. Let's get the pencil. That's 1, 2 across, and 1, 2, 3 down. That's right. So if you'd drawn your vector something like that, in fact, you don't have to label it as a boldface A. You could have labelled it as a normal A and drawn an arrow over the top. then that too would have been fine. Obviously this arrow looks different to this arrow because I'm using a different scale now, but you're still going 2 across and 3 down. And so long as you're consistent with your scale throughout all your exercises, then you're absolutely fine. If you'd have drawn a vector going up, that would have been wrong. If you'd have drawn a vector going that way, that would have been wrong. You just have to make sure that your vector from the tip of the tail to the tip of the head is 2 units to the right and 3 units down. Okay, so how did you get on with that question? Ready for the next one? Okay, which of these vectors is the same as vector A? Take your time, pause the video. When you're ready with the answer, or when you're ready to receive the answer, just press play. Okay then, so how did you get on? Alright, in this question we're told which of these vectors is the same as vector A. Well, vector A is 4, 3, so it's 4 to the right and 3 up. So we've got our grid here. So let's look at B. Well, it seems to start just a little bit off the square, but it ends just a little bit off the next square. So I'm going to ignore that square and pretend that this starts at this square, because I think the amount that the arrowhead goes over that square is about the same as the amount that the tail goes over this one. So I'm going to count this as a whole square. So this is 1, 2, 3, 4 squares to the right, and 1, 2, 3 squares up. So first time lucky, so that is actually the correct answer. So B is the same as A, but let's just check if that's the only correct answer. Well, vector C is pointing in a completely different direction, as is vector D, so those two cannot be the same as vector A, and they certainly don't look anything like vector B. E is pointing in the right direction, but it's too long. In fact, I would say that E is probably a scalar multiple of B, but that's for another lesson. The point is, E is not the same as B, so B is the only correct answer. Okay, ready for the next question? Okay, can you put vector A in component form? Okay, take your time, pause the video. When you're ready for the answer, just press play. Okay then, so in this question we're asked, can you put vector A in component form? Well, vector A here, we've got our arrow, and it seems to be pointing 1, 2, 3, 4, 5 units to the left of the tail. So it's 1, or the tip of the tail I should say, is 1, 2, 3, 4, 5 units to the left, and it's 1, 2, 3 units down. I'll double check that because I don't want to mislead you. So there's the tip of the tail. I'm counting 1, 2, 3, 4, 5 units to the left, and 1, 2, 3 units down. So A is equal to -5 and -3. Okay, so how did you get on with those questions? Alright, if you found this video helpful, don't forget to click like, Don't forget to subscribe if you haven't already, and turn your notifications on so that you're told when I upload videos. And if you're taking your GCSEs this year, I'd like to wish you all the best with your revision and all the best with your exams. Don't forget to comment if you have any suggestions for other videos that you would like to see me make, and I'll look forward to seeing you in another video.